Hello, everyone. My name is Di Xu. I'm a system architect at Alibaba Group. And today I'm going to talk about the idea on distributed shared memory architecture. So in-memory database, PageRank, graph computing, etc. make up an important class of data-intensive applications. To support such large-scale computations, people often deploy a cluster of server nodes connected via a high-bandwidth commodity network. However, this solution requires programmers to carefully handle the data placement and computation parallelism in order to reduce the overhead on data movement. And it usually involves replications of data on different server nodes that cost expensive DDR capacity. Without memory sharing, a physical server becomes the boundary of resource allocation and it's difficult to achieve high memory utilization. The figure on the right is showing Alibaba's production cluster traces. For each server node, on average, the memory utilization is below 50%. So our goal here is to build a shared memory layer that is transparent to the applications so that to ease programmers' work and also can lower the system memory TCO by reducing data replications and improving memory utilizations. The distributed shared memory architecture is motivated by three data center trends. Number one is data-intensive applications that require data sharing. Number two is emerging high bandwidth, low latency cache coherent interfaces that enable memory expansion within a compute node or cross nodes. Number three is storage class memory technologies that bridges the gap between DDR and flash. So Compute Express Link or CXL is one example of cache coherent interfaces. With CXL, application can perform native memory load and store instructions to access both local and far memory in a global memory space. The figure on the right is showing memory and storage media hierarchy. So compare with DDR, storage class memories offer advantages such as capacity expansion with lower cost and increased data reliability due to its persistency. So in order to connect individual server nodes to form a shared memory pool, a high-speed fabric is needed here. So in our proposed architecture, we will evaluate two different approaches. One is RDMA. So with the introduction of 400 gigabit per second network, RDMA for far memory-based system becomes feasible. The second one we're going to evaluate is Gen Z. So Gen Z is a high performance, low latency memory semantic fabric, and it's suitable for building a large capacity scale out shared memory pool. The figure on the right is showing the distributed and shared memory architecture that we are proposing. In this figure, the tier 1 memory is composed of local system DDR, which has the best performance and is intended to serve the high SLA workloads. Tier 2 memory is a pool of storage class memory that has large capacity to supplement tier 1. Here, we plan to use FPGA. FPGA can support RDMA or Gen Z protocols for interconnecting with each other to form a high-speed data plane. And in addition to that, the FPGA can also serve as a near-memory computing engine that accelerates typical operations such as compression, encryption, etc. This is all I have today. Thank you very much for listening. And if you have any questions or if you would like to collaborate, please reach out to me. My email address is on the first slide of the presentation. Thank you.